Hey guys, welcome to the fifth lesson on advanced C# programming. Today we're going to be talking about generics. We're going to talk about what generics are, why we use generics, and how we use generics. So I personally think that learning generics is the easiest by actually seeing it in examples, but I still want to give a basic definition of what generics are, or maybe not exactly what generics are, but why we use them. Because once you can understand why we would want to use generics, it just makes sense. So essentially, generics allow us to not have to hard code data types into whatever we're designing. So if we're designing a class, instead of having to hard code certain members, and let's say we have an integer member, we can use generics to tell when we're writing the code, we can tell the class what we want that class to be using. So instead of using an int, we could say use a double instead when we're writing the code. So instead of having to hard code that data value in, we can tell it while we're actually writing the code. So that uses the class. Now, you may be saying, why is that useful? And there's a couple of reasons. Let's say we're building a class that does multiple things. And this is really a good way to look at this is when we're building collection types. So let's say we're building some kind of wrapper class around a basic list. So this we're just going to make a class that holds things in an array. I guess that's the easiest way to do it. Now, if we were writing the code for this, let's say we wanted it to hold integers. We would, behind the scenes in this class, we'd make an integer array that will hold our values, which is okay. But then what happens when someone wants to start storing doubles in it as well? What do we do then? We would have to build a whole new wrapper class and make this whole new collection that will be a double array. Now that's the reason why we have generics, and this is the reason why, or these are the problems that we want to fix. We don't want to have to make multiple classes so that we can use multiple types. So like I said, if we have two collections, let's say we have my int list and my double list, we have to create those two separate ones if we want to store integers or if we want to store doubles. Let's say then we want to make another one. What if we want to store strings? How are we going to do this? What if you want to store an array of strings? We'll have to make a whole new class, a whole new collection that will store strings. And like I said, this is what generics fix. By using generics, when we're creating an instance of the class, we can say, oh, I want this one to be a string array, or I want this one to be a double array. That's the benefits of using generics. And I'm going to show you what I mean by this by doing this example of a basic list. So let's start off with building this integer array class wrapper. That's what I want to start out with, and so that we can see the problem and see how we can fix it with generics. So the first thing I'm going to do is I'm going to create a new class. And my new class, I'm going to call it, my int list. My int list. I'm creating a new custom list, and I called it my int list. Now, this is going to be a really basic class. All I want is, behind the scenes, I'm going to have a private integer. I guess I could do an integer array. I could use a list also, but I don't want to get into generics yet. So I'm just going to use an array. So I'm going to say private int, and this is going to be my int array behind the scenes. In my constructor of my int list, I'm just going to give this some memory. So int array equals new int array. I want to say it has 5 slots. This is just a little hard coding behind the scenes. So there's my behind the scenes collection. So I'm building this wrapper around this array so that I can call. I want to make 2 functions. Actually, I'm just going to do, I'm going to make 2 functions. The first one's going to be an adding function that you can add a value to this collection. So public void add int the value that I want to add into this. Okay, so I need one more thing before I can actually do this. I'm going to create another private member, and this is going to be my count. And my count is going to be how many elements I have in this so that my add function knows what to do. So now what I'm going to do in my add function, I'm going to go int array sub count equals value, and then count plus plus, so that will set me up for the next one. I also want to put in a check to make sure I don't go out of bounds. This is just like a little extra things. So if count is greater than or equal to 5, then I'm just gonna return. I guess I can just do it that way. So by putting this check in, now my add function is safe. So this is, let me go over this one more time. I have my behind the scenes array that this is going to hold my integer values that are passed in. When my add function calls, it makes sure that we're inside the bounds of the array. And if we are, then we'll just access the count slot, dump the value in that or whatever it's passed in, and make count plus plus go up by 1. So next time someone calls an add function, they'll have somewhere to add it. Okay, so and then the last thing I'm going to do is I'm just going to create a show function, so public void show, that will just show all the elements of the array and print it out. So I'm going to say for int I equals 0, as long as I is less than, now let's go 5, I plus plus, and then I'm going to go console.writeLine, int array sub I, and that's it. So this is my basic wrapper class. I created this little basic class with an array in the behind the scenes, and all the user has to worry about is calling add or show, and they can add things to this array and show it. I didn't make a remove function because I don't want to get into data structures too much. So I'm just trying to emphasize this point of generics. So let's go ahead and just test out this data structure. So I'm gonna go my int list equals new my int list. I'm gonna go list.add 5, 55, and 68. I'm gonna add those three, and then I'm gonna go list.show. And let's go ahead and run it. And as we can see, everything's working fine. I added 5, 55, and 68. Now, the reason why I'm getting these 2 extra zeros is because inside of my for loop, I'm going up to 5. I could change this just to count, but I didn't want to confuse anyone. So now if I go up to count, now if I run it, now we'll just see the values that are just stored into the array. So we have that 5, 55, and 68. Now, this video is not about data structures. This is not about building this class. It's more about the reason why generics are important. So as you can see, this works. Now, this is the problem. I have this list that you can add things to, and then you can show and you can see the values that are stored into it. This is what I have. The problem arises when I try to add a value that I can't use, like 55.5. What happens here? This is the problem. I'm getting an error because it's behind the scenes, I'm storing it into an integer array, and my add function requires an int to be passed in. That is the problem. So if I wanted to now make a collection type that can store doubles, which like this 55.5, I would have to recreate this entire thing that utilized a double instead. Same thing if I wanted to add maybe a string, like hello. I wanted to add this. I would have to recreate this class that does it, because as you can see, I called it my int array because I knew I wasn't going to use generics, and this is only designed for an integer. So this, hopefully you can see why we want to use generics. So now we see the problem and why generics are important, let's go ahead and implement generics to fix this problem. So let's go ahead and I'm going to leave that 55.5 and I'll make this 56. Okay. Let's go ahead and implement generics now. So inside of our class, this is just syntax. Next to our class definition, now if you're coming from C++, this is slightly different than templates, the syntax at least. So inside of this, I'm going to use generic syntax, and these are the angle brackets are greater than and less than signs. So inside of this, I'm going to specify an identifier. I'm going to say T in this case, and I'm going to put this T next to my class. And what this is signifying is that this T can be used anywhere inside this class as a data type, and this data type is resolves to whatever is passed in when they're creating the class. So now that I have this T, I could put this T anywhere I see an integer. So let's go here, here. I see it there. In my add function, I see it. Actually, no, this should stay as an integer. Sorry about that. The count is always going to be an integer. That doesn't need to get changed to a T. Where else do we see int? That's fine. Okay, I think that's it. So all I changed was my array behind the scenes is now based off of T. Its data type is now T, and my add function takes in a parameter of type T. So what we did was, now when the user goes ahead and creates an instance of this class, he'll specify what type he wants to use, and then that type will be replaced throughout here where the T's are, thus allowing us to create an array of any type rather than it having to be an integer. So if we switch back to here, we'll see we're getting errors, and we need to specify our type. So the first one I'm going to do is I'm going to say a double. There, double here, in the angle brackets. And now that I did that, now my class is set up for generics. So now, as you can see, the add for this 55.5 went away, and when I run it now, everything works, because I'm saying that this is an array of double now. If I were to, let's go ahead and look at the IntelliSense for the add function. And as you can see, the IntelliSense says that it's looking for a double value, even though behind the scenes it's a T. It says double because we passed in double there. If I go ahead and change this back to an integer, watch what happens. We're going to get that error again right here because the add function is now looking for an integer rather than a double. I could change it to a string, and now they'll all get errors. But I can fix that by just putting everything in between quotes to make them string values. And by doing that, now if I run it, everything will be working again. So this is the first part of generics that we're going to go over. This is the part where we're marking our class as generic. The entire class is a generic class, and then we pass in the parameters that are necessary. Now, I'm not going to go into this too much, but I'm just going to let you guys know you can have multiple generic parameters. So I could have T and Y hypothetically separated by commas, and now Y is another generic parameter that the user will have to add in here. So like int, string and an int, if I wanted to do that. Okay, so there's another aspect of generics that I want to touch into really quickly. How we have it set up right now, our generic parameters can be any value that the user passed in. Now that could be a good thing or a bad thing. You know, for a generic collection like this, it's probably a good thing. But sometimes when we're using generics, that will not be a good thing. And the reason is because that it can be anything, and because it can be anything, it's very hard for us to do specific things to it inside of our code. And what I mean by that is, like, if I had a generic parameter and I passed in let's say a class called employee as the parameter, I couldn't manipulate that employee really because I don't know what type it is when they're passing in, because it's a generic parameter inside this class, so I couldn't really manipulate it and call functions on it that easily. So this idea introduces us to a concept called constraints. And constraints allow us to specify or make the parameters that are passed into the generic arguments more restrictive, meaning that you can say, oh, the parameters that are passed in must derive from this class, or they must implement this interface, or they must be a class, or they must be a value type, or things like this. You can specify these things by using this concept called constraints. So let's go ahead and do an example of a basic constraint scenario. Let's go ahead and build a little class hierarchy. So I'm going to go ahead and create a new class. And my base class that I'm going to have is going to be an animal. Okay. My animal, I mean, we can just give it some properties. An animal has a name. Let's say all animals have a name. So public string name. So all animals have a name. And we'll also say that all animals have an age. And that's it. That's my animal. My next class I'm going to build, I'm going to keep it in the same file. I'm going to build a dog. Because a dog is a type of animal, so my dog is going to derive from animal. And then on top of that, my dog, I'm going to say that a dog has maybe an owner. And I guess a dog can also maybe we'll do type. So like what type of dog. So how this is working, we have a base class called animal, which has a name and an age, and then a dog, which has more specific characteristics because it's more specific type of animal, and it's an owner and a type. But a dog also has a name and an age because it derives from animal. So that's my setup. Now, inside of my generic class, I'm going to be allowing this class to be storing animals into this array. How it's set up right now, it would still work perfectly fine. My show function is going to be a little messed up. That's why I'm just going to, I'm just going to comment that out right now because I don't want to deal with that and confusing people. I just want to deal with adding. So how I have it set up right now, I can create some animals. So let's go animal A1 equals new animal. And I'm just going to say a1.age equals 5, a1.name equals Bob. I don't know. And let's just create one more animal. A2, and he's 15, and his name is Fred. Whatever, it does not matter. So I have two animals. So now using the basic generic setup, I can still do this. I can still go in and say, what should we call it? Animal. So we're going to say animal and animal. So now by doing this, our generic class right here will be able to take in animals into the array. But there's more to this. Now we need to start talking about constraints, and we'll get into that here in a second. Okay, so now that I have my generic class set up with animal, I could, if I wanted to, go list.add, and as you can see, it's asking for an animal as a parameter. So I'll add A1, and then I'll add A2 as well. So I can do that. So I can add these things to my list. Now, also, one more thing, because it's an animal, it's saying that it's a list of animal, I could create a dog, D equals new dog, D.age equals 2, D.name equals, oops, did not want to do that, D.name equals, I don't know, Tim, D.owner equals Frank, D.type equals poop, yeah. Okay. So now I have my dog set up. I can also go list.add D and add my dog to this collection because a dog is an animal. So that's the basic setup. So now that I have this, now let's talk about the problem that can arise by doing this. So I know that it's going to be an animal, right? Which could be an animal or a dog. Because I told it that it's going to be an animal. But inside of my list, it's a generic parameter. So I don't know what the type will be. So like, let's say in my add function, I wanted to display its name of the animal when it's added into the collection. I couldn't do that right now because value dot, and I don't know what it is. I don't know. It could be anything. All I know is that this type derives from object. That's why I see these things. But I couldn't actually get its name right now. Now, if I really wanted to get its name, I could. I could get the name of the animal when it's getting added in if I did some manipulation. So, like, watch this. Console.writeLine. Let's go value as an animal. So I'm saying treat the value as an animal and then get his name. Now, this will work, but even though it displays the animal's names, there's a problem. And the problem is, what if it isn't an animal? What if the programmer, made another list of type int? Then it would be problems, we have to do checking and blah, blah, blah. It would just get ugly. So that's the problem. I could actually demonstrate this. If I went... Let's just comment this out really quickly. And let's say this is an integer. So let's say someone else wanted to use an integer, and they did list.add5, and they ran that. And as you can see, now the program crashes, and we get an exception, because when it does this conversion right here, it's becoming null. But I'm not going to get into that. But that's the problem, because because anything can be passed into here, I can't just say, oh, this is probably an animal. That does not work. We have to actually limit it somehow and limit the user's ability to pass in anything that they want. And that's where, like I said before, constraints come in. So how do we use a constraint? Okay, let's put this back. The constraint I'm going to use is, let's go ahead and take this away. I'm going to say, in my class declaration, I'm going to say where t : and then I'm going to say where t is an animal. So by adding this little syntax next to my class, I'm specifying a constraint. I'm saying that the t can be anything that derives from animal or is an animal. So that could be an animal or a dog. And because of that, now I am safe. I'm safe. So in here, if I want to display the name, now I can just go console.writeLine value dot, and as you can see, age and name appear. I don't even have to use the as keyword to convert it, because it has to be an animal because of this constraint. So now if I do that, now it works no problem. Now, if we go back to the problem where, what if they use integers instead? Well, let's see what happens. If I go int, look what happens. We're getting errors. And the reason why we're getting these errors is because we put our constraint in. We're pretty much saying that there's a constraint that it has to be an animal, and ints are not animal. I could do a dog, however, because a dog is an animal. So this still works in the constraints. So yeah, this all works fine. So let's go ahead and undo this. So let me just quickly sum up this one more time. Constraints allow us to restrict access to, or restrict what the generic parameter of your class can be, or method, which we'll get to. So these constraints, now you may be saying, okay, why do we want that? And the reason is, if we want to be able to interact with these objects and interact with these things inside of our class, we can use constraints to help ensure that what we're actually talking about is it. So if we add a constraint of an animal, we can be sure that when we start using that generic parameter, that it is an animal. And if we know it is an animal, then we're good to go. Now, there are many other reasons why you may want to use constraints. And when you're using generics, you'll just run into them and be like, oh, well, this is a good use for a constraint. And another cool thing is you can add multiple constraints. So that's what makes it more powerful than maybe just making it the array of type animal. You could use multiple constraints. So you could say, if it's an animal, if it's this, if it implements this. So you can do all those kinds of things with multiple constraints. So let's go ahead and let's talk a little bit about generic methods now. And what you need to know about generic methods is that they're the same exact thing as generic classes, except that they are on the function instead. So let's go ahead and I'm just going to interact. I'm going to forget this list right now. I'm going to interact with our animal class. And I'm going to create a function on our animal class that just, no, actually, let's go on the dog class. That the function will just be public void bark and whatever, or maybe speak is better, speak, and whatever you pass into its parameters, it will speak, whatever it is. So we can use generic parameters, because let's say if I did int value right here, then our dog could only speak an integer, hypothetically. Let's go ahead and test this out. So our animal, a1 dots. Oh no, it's a dog. Hold on, I forgot. It's not an animal, it's a dog. So let's go ahead and get our dog. So if I wanted to do d.speak, I need an integer value, and if I run that, we get the 5. If I try to do maybe hello, we get an error. So that's or maybe a reason why we want to use a generic parameter. A generic function. So inside of our animal class, I'm going to convert this into generics. So the syntax is the same. I'm going to put in my little thing there, put my t there, and then we're good to go. So now, instead though, when we call the function, I'm going to specify the generic here. So I'm going to say string, and then now hello will work. Let's go ahead and run this. Hello will work now. Because I'm saying I'm passing in this string. So by doing that, if I highlight the speak now, it says that it's looking for a string value instead. If I made it an integer, then it's looking for an integer value. So I put 5 in. That works now. If I'm looking for a double, I can put double in, and I can put 5.5. And that works. What else? Let me see. Okay, where's that? Single, that works fine. So by doing a generic function, it allows us to do the same thing as a generic class. We can specify what types our functions should be, and there are lots of benefits of doing this. I can't name them all, but there's just reasons why. And this is maybe one good example, that your speak function can speak any type of data, hypothetically. Now, once again, the problem will arise where we need constraints, and the same thing applies with functions. I can add constraints to this, so I can say where t is, I don't know, a dog or something. So I can add constraints as well, and this constraint right here should make this error, as you can see it does. But if I did dog, but then I don't have a dog. Okay, anyway, I could do D probably. Okay. But anyway, my point is that you can add constraints to functions as well that allow you to help restrict. And that's really all constraints do. They help you restrict what can be passed into these generic parameters. Because by default, a generic parameter can be any data type that you want. So constraints allow us to help specify. And also, you can have multiple generic parameters, like I said as well. It doesn't have to just be one. Alright, so that's going to be it for this lesson. We talked about what generics were, why we used them. We looked at classes with them, generic classes. We talked about constraints a little bit, and then we talked about generic functions right now. So I'm just going to leave you off with, this is the base, this is an introduction to generics. Like I always say, if you want more details and more about generics, just write a comment and we can go into more of the advanced things. But like I said in the beginning of the video, once you understand why we want to use generics, it comes really easily. And I just want to add that generics can be used with lots of things. Generics can be used with structs, generics can be used with interfaces, generics can be used with delegates, generics can be used with lots of things. So once you understand it with this, you can apply generics to delegates, you can apply generics to interfaces, and you can apply generics wherever you most likely really want. So that's it for this video. I hope everyone enjoyed it, and be sure to stay tuned for any upcoming new videos. Thanks for watching.